So let's go to the lecture 2 assets. You'll notice there is a script in there. Go ahead and double click it. If you haven't opened it up already. Again, make sure that you're opening it up in Nuke X. You will know that you're in Nuke X because you will see up at the top it says Nuke X here. So we're going to go over a few of the settings here in our viewer. It's important to understand this, the nature of how Nuke kind of works and how it uses its channel information. All right. So let's just start with the viewer here. And let's look at these buttons up here at the top. These two buttons you guys should be at least familiar with. This RGB is just what we're viewing. We're viewing the color channels at this point. Of course, we can look at individual color channels within the viewer if we select it, or we can use the hotkeys, right? This is just the color space of the viewer. Remember, we talked about this in lecture. We're just setting our viewer to the color space. You guys are probably going to leave this at sRGB and never change it, at least not in my class, all right? But we have these two buttons here that we need to discuss, all right? Something that Nuke does with its channels is it likes to put channels in groups of 4. Okay, so when you have an EXR file with all those thousands of channels, it's going to organize them into groups of 4. Now, these groups are called channel layer sets. That's the full name of them. Now, the channel set layer that we work in is what we call the first channel set, which is just a generic channel set. Right? So its name is literally just the channels, RGBA. Now, what's to the right of it is just what you want to represent the alpha of this channel set. So in this case, it's just saying, for RGBA, let's have the alpha represent the alpha. But there could be a situation when you might want to use another channel as the alpha. So if there was channel information here, you could say, okay, RGBA channel set, but for that A, I'm using the red channel as the alpha. Okay, that's all that's for. Again, most of the time you'll leave this stuff kind of where it's at, all right? So let me look at an EXR here to kind of demonstrate this. When I load an EXR into the viewer, we are looking at the RGBA channel set of this particular EXR, which in this case is the reference file, right? What you're going to match, okay? If you look, we have the ability to look at all the different channels inside the EXR right here. Now keep in mind, we're just viewing them. I'm not extracting anything out of the file yet. This is the viewer, this is just viewing the data in the file. So for example, I could say, let me just look at the diffuse. It's the color with some amount of shading. And you can have different types of diffuse. It's just going to be the different types amount of shading on it. No shading, they'll sometimes call it just a material color pass. It's a type of diffuse, but it could just be called material color. Now, if you guys go to the game world, what is the diffuse pass called in the game world? Albedo. Okay, so we can look at the individual passes. I can look at there's the hanger spec, or there's the hanger occlusion or whatnot. Keep in mind that these render passes have their own red, green, and blue channels. So for example, this is the reflection pass. This reflection pass has a red channel, a green channel, a blue channel, and an alpha channel, which in this case it's empty. Okay, so these channel sets are usually grouped to 4, right? And again, like I said, how we can move and manipulate this stuff is kind of what separates Nuke apart and makes it so unique. So let me explain to you what's happening here. I'm going to set this back to RGBA because you remember we work in the RGBA. But what I'm going to do is I'm going to tab in a shuffle node. Watch what I'm going to do in the properties of this shuffle. All right. If we look at it right now, pretty self-explanatory what it's doing. It's saying the input, it's grabbing that RGBA channel set, which is the reference, and it's shooting it out to the right to the RGBA channel set of the node. So essentially, it's just passing the information through unchanged. That's why you're still seeing the reference. But let me grab one of those other channel sets. So let me grab, we'll do hanger reflection. Okay. So now what has it done? It's now taken those channels that are in the hanger reflection, right? So red, green, and blue and alpha channels that are from the hanger reflection, and it's pouring them, or it's shooting them out into the RGBA channel set of the shuffle node. So that's why we're in RGBA, but now I'm seeing that hanger reflection. I've just rerouted kind of where the data is coming from and where it's going. Now, here's a little trick I can show you guys with this shuffle node that you can do. First, you can create a little postage stamp so you can visually see what you're going to render out by holding down Option and hit P. See how now you can visually see this is the hanger reflection. But if you go into the node tab of the shuffle, you can add in this little simple expression. You can do open bracket, value in, close bracket, all right? Now when you do that, you'll notice the shuffle node will tell you
the name of the particular render pass that you're shuffling in. Right? So again, it's not something you have to do, but this is just beneficial. It just helps you. You could rename your shuffle node, but there's no reason to do that if you just do this little value in expression, because it goes ahead and gives you the name anyway. So now that you have this node, guys, all you need to do when you're setting up your truck, you've already got the node, you've already got the expression in it, Command C, Command V, Command V, Command V, Command V, Command V, right? To get all your passes, we'll just create our dots or our little elbows, line all this stuff up. Right, so you can set this stuff up relatively quickly and get all your passes shuffled so you can start comping them together. It's not that it gives you more control, because obviously you have the most amount of control in Maya, right? But it's just being able to give you results quicker, as opposed to going back into Maya and having to re-render a reflection pass. You can just, in the comp, turn the reflection pass down and you're done. Sometimes, yeah, it's just good to just see the data that it's grabbing. So look, as I keep updating this, you notice I did hanger spec, it updates the hanger spec. This one will be hanger occlusion. So just copy the shuffle and just reset its inputs. That's how we shuffle channels out of an EXR. But sometimes we need to move channel information from one stream into another. Okay, so let me give you an example of that. Let's say I have this particular image here, this painting, this matte painting. So if I look at this is just a straight up matte painting. All it has is a red channel, a green channel, a blue channel, a completely opaque alpha, and that's it. Right? If I look at the channel sets, there's nothing else in this particular image, just 4 channels. Now I have rendered a separate depth pass. All right, so I need to get this depth pass into that file, into that image, right, into that matte painting, right? And again, a couple different ways we could do this, right? We're going to use first with a copy node. Again, this is another type of channel node that we can use where we copy information from one input into another. Now, first, look at this pass. It's just grayscale. It doesn't matter what channel I use. If I switch between red, green, blue, it looks the same. So what we're going to do is we're going to say plug A into our depth, and we'll plug B into our main image. And that's another thing I want to tell you guys. Data information always follows on that second or B pipeline of your composite. So your main stuff is always going to be on the B side, okay? So look in the copy node what I'm going to do. I'm going to say, okay, let's grab, what channel are we going to use? The blue, and copy it into a depth channel set. So if I look, you're going to notice, oh, look, there's all these crazy, there's that depth Z, right? So what I've done is I've grabbed that blue channel and poured it into the depth channel of my matte painting. So now when I look at my matte painting, right, there's my matte painting, but guess what? I got that depth channel set now. If I look at it, there's my depth, all right? It's in that file. Now, of course, I could render this out as an EXR and have it all contained, hand it off to my next person in the line, they'll have it, they'll have the depth with it, everything will be good. Now let me show you something you can do with depth, because this is actually pretty cool, all right? Again, a lot of post effects are done in post. I know that sounded redundant. All right, but for example, what I'm trying to say is like a depth of field effect, you're never going to render something like that. You're going to do that in post. So let me give you an example of what I'm talking about. For a depth of field, if I use something called a Z-depth or ZD focus, because I have that depth information embedded in the image, I can use that to basically refocus the shot. So you'll notice, man, this monitor is really dark. Everything's out of focus, right? But because I have that depth, I can say at any point, for example, I want this particular building to be the one in focus. You just line it up with that depth and it'll adjust it accordingly, right? Now you'll see as it updates, that's the building that's in focus, right? Or let's say I'm not doing anything, this is post-rendering, guys. So let's say, okay, no, I want this building to be in focus. We're gonna grab the focal point and bring it back there. And then go ahead and adjust this stuff after the fact, right? This is why you don't want to render with this stuff, because you can do this stuff in post and it looks just as good or just as well. Now, not only can you do a ZD focus like this, you can also do something called a Z slice. Now, this is really cool because you can cut the scene up in 3D. Remember, this is a 2D image, but I'm about to cut it up in 3D using this Z slice type of technique. All right, now there are going to be limitations to this because I'm using an 8-bit file here. But it'll give you guys the idea of what you can kind of do with this. So if I use the depth as my depth channel, you can see basically how it's splitting it. And if I move the center of the slice, you can see how we can kind of slice through the shot, right? So what you could do is you could isolate your buildings, and then from here, apply them on a card, put them in 3D space and start kind of laying them out, right? So we can do one card like this. We can maybe have another Z slice that slices another area of it, set it up on a card, and keep going on stuff like that. Now, again, that brings me to the bit depth issue, which we'll talk about so you guys can see the bit depth issue and why you always want to render stuff like this at the highest bit depth. But let's say we want these buildings kind of here in the foreground. Let's maybe adjust this a little bit and get something more like that, just so you guys can see kind of what I'm doing here. The 8-bit artifacting is this right up here. Okay, right. So you guys get the idea, right? See how I can kind of separate this stuff. Again, doing this stuff after the fact, right? This is post 3D. We're working in a completely 2D kind of thing here and then going back into 3D. Now, the limitations of dealing with bit depth and why you always want to render these types of passes. So any type of pass that's going to be simulating motion blur or position passes, normal passes, any type of data pass, depth pass, you always want to render these out at the highest bit depth. So let me show you an example of what I'm talking about here. So I have this image here, and again, we could do the depth effect on this too, but what I want to do, sometimes you want to put something into the scene, kind of place it in 3D space. So again, you could either use a Z-slice to do that. So let's say I have some noise here, right? And we're just going to pretend, right? We're going to pretend this is some smoke here, all right? And we want to place this into our shot. So what we're going to do is we're going to, like I did before, use the depth from the shot and add it into our smoke. So we're going to do, let's do a shuffle copy this time. Again, it's exactly like the copy node, it's just kind of a different way of doing it. So again, the second input is where my main passes through, and then we're going to add the depth in. So on my input 1, again, input 2 is just passing through, that's the smoke, so input 2 goes this way. And then input 1, we're going to say, let's send it to depth, all right? And I'm just going to grab the red channel. Again, it doesn't matter, so the red channel would work. So now if I look at the shuffle copy, still got that smoke there, but you'll notice there's that depth channel set that has that depth information. There we go. Okay, so let's start cutting this up so you guys can see what it looks like. I'm going to go ahead and comp this over, and we will do a Z slice, and I will select my depth as my Z. All right, so here is where we're losing data from the 8-bit file. You can see it right here, all right? See this? This is the compression. You can almost see it in the rows, right? Splitting through. So when you're trying to cut through this scene using an 8-bit depth pass, it tends to look a little odd, right? You get these weird kind of mosaic or these just weird looking patterns here. So if I go through the center of the slice, now let me show you guys when you use a 32-bit data file as your depth. All right, so I got to adjust a few things here because there is depth. We want to grab depth and put it into depth. Okay, so now look at this. It's going to be much smoother as I go through this. Also, this is a 4K image, but you can already see we're not getting into that weird banding. It's going through nice and easy. It almost looks like it's almost the inverse of like coming out of water or something like that. So again, look how fine-tuned these values are. But you see how nice and smooth that is? You're right. You're not getting any of that type of banding as I'm going through this. Right, and again, that's what those just that extra data, having those values between your darkest and your brightest, give you, right, with this type of control. So this is just to demonstrate, right, when you're rendering these data passes like we do as compositors, you always want to render these at high bit depth for reasons like this when you're trying to do your comp work.
Start talking about some color here. All right, so just to basically kind of go back through the keynote, just kind of more a working format here. All right, so we've got our primary colors, our red, green, and blue, right? Now, if I add all these together, I'll get white, all right? Now, let's talk about how we can make our complementary colors, all right? Remember, we're in an additive process, so we're gonna add our primaries together to give us our complementaries. So let's start by making cyan. I'm just gonna merge these two together, and yep, there's cyan, so very good. All right, so someone else answer, how do I get yellow? Red and green, yes. Take red and I take green, add them together, there is my yellow. So the last one, right, magenta. You take blue and red, add them together, that gets you magenta. So if I were to add green to this, what am I going to get? There is white, okay? All right, so again, that's the basics of an additive color process where we're just adding our colors together to get us to white, all right? So everyone go down to the basic CC adjustments here. I want you guys to load in this IAS Right Image Tools Analysis node. You're going to see what kind of pops up here on your viewer. So what we have is basically a ramp off to the left, and then that ramp kind of graphed in a visual form off to the right. Basically, the low values of the ramp are here. This is the lows, this is the midtones, this is here, and this is my brights, what are here. So we're going to go over some common color correction adjustments so you understand what they're doing to the image. We can visually look at this plot scan line and see what it's doing to our ramp. So you've heard things like multiply, gain, offset, gamma, black point, white point, all right? But what do they do to the image? Well, this is why we have this, so you can visually see what's happening to your ramp as you make these adjustments, all right? So you'll notice we have a grade 2 node right underneath the ramp. Go ahead and double click it and open up its properties. So I'm going to kind of do these out of order. We're going to start with gain. So I want everyone to take the gain slider from their grade 2 and drag it to the right and watch what happens to your plot scan line and your gradient as you do this. So as I grab the gain and lift it up, look what it's doing to the plot scan line. Now it has white clip on or white clamp. Let me turn that off. So you can see with the gain adjustment, all values are being affected except 0, right? What's absolute black or what's 0 is not moving. So when you do gain affects all your values except for what's absolute 0. Now I want everyone to grab the multiply and do the same thing. Drag it left and right. And you'll notice that it does the exact same thing as gain. In fact, gain and multiply are doing the exact same thing. The math is the same, right? Now you guys might ask, why do I need two things to do the same thing in the node? There's a reason why you would want both. And when we start doing some color correction, you'll see why. So we did gain and we did multiply. And we saw that gain and multiply essentially do the same thing. So let's go above gain and let's grab our lift. I want you guys to grab the lift, to drag it to the left and right and watch, or to the right and watch what it does. Look at what it's doing to the plot scan line and also look at what it's doing to the gradient. So the lift is lifting your darks or your black values. It's affecting every value in the image except what is absolute 1. Gain affects everything except 0 and multiply as well. And the lift affects everything but is 1, right? So it's kind of the opposite. I want you guys to go down under multiply and look at what offset does. So grab offset and drag it to the right. Now offset can sometimes be called add, right? Because it's just adding a constant value to every value in the gradient. So as I increase this, it's adding this 0.39 to my darks. So now my darks are at 0.39 and then everything afterward. So let's grab gamma. Watch what gamma does. All right, gamma has this type of rubber band effect. You can even kind of start to create something that looks similar to an sRGB curve, right? So gamma affects basically everything in the middle. Notice the two things that it doesn't affect are what's absolute 0 and what's absolute 1. So gamma will not interfere with black or 0 and white or 1. And you can see it's kind of a logarithmic curve here. Okay, so the last two are black point and white point. And this just defines where your black point and white point are in the image. So if I grab the black point and drag it to the right, what I'm doing is essentially clipping these values out. So now these gray values that were gray, I'm just pushing them to black. And you can see it represented here in the plot line. It's getting clipped or clamped here. Now, the reason why it's getting clamped is because by default in the grade node, you have a black clamp on. If you turn this off, you'll actually get some weird types of effects happening here when you have kind of values dropping below 0. So it's usually a good idea to keep this on, your black clamp. The same with the white. If you grab the white point and start dragging it to the left, it's just clipping out the whites. Look at your gradient as you're doing this. Notice the white clamp is not on, but if you were to turn the white clamp on in the grade node, it would do the same thing. So it's just clamping those values. All these values that were here are now pegged at 1 or clamped to 1. That's why all this looks completely white, and then we don't start seeing the gradient till right around here. So those are basic color adjustments, right, and what they do. And these are primarily the ones that you'll use, especially with the grade node. Because the grade node gives you a lot of information. And we'll go through what each one of these settings mean. Like most nodes, you kind of start at the top and work your way down. So we have this shot here, all right. Again, with the grade node, we're just going to, let's see if I can kind of make this a little bit better here. There we go.
Let me see if, okay, that's better. It looks weird on the screen, guys, if you guys watching this, but the projector is so dark, I have to kind of turn it up so the guys in class can see it. Okay, anyway, black point, right? What is this for? It's what you want to be black in your image. Whatever you sample, it's going to turn this to black. So let's say I want this value to be black. I'm going to grab the color picker. I'm going to hold down Option Command and click and set it to black. All right? It just takes whatever value that you sampled and basically pushes it to black. All right? That's what a black point does. You're setting the black point of the shot. So if I set the black point, what do you think the white point does? Yeah, it sets what you want to be white in the shot. So let's say, what should be white in the shot? Option Command and click. Now, you guys notice I'm holding down that Alt Option modifier, all right? If you command and click, watch when I command and click, all right? You see why that's happening? So what's happening is I'm sampling that value. Nuke is seeing the value that I sampled. It's changing it, and then it's seeing that value I'm sampling. It's changing that, and now it's seeing that it's kind of getting in this endless loop, which is why it's creating something that looks really jacked up and whacked out, right? So when you hold down that option modifier, you hold down Option Command and sample, it samples before the node, all right? In reality, what it's doing is just sampling the viewer, bypassing everything in the node graph. So now we have lift and gain. What are lift and gain for? Well, lift and gain are for setting those black and white points that we've just set to whatever color we want. Okay, so if setting the black and white point is saying this is what should be black in the image and this is what should be white in the image, the lift and gain say turn this black to this color, that's the lift, and the gain would be turn the white point to this color. Now you have additional settings, the multiply, which is just a multiplication, which can sometimes be called brightness. If you guys come from another program, sometimes brightness is called multiply. All right, you have an offset, which essentially is an add. This is going to give you a very milky look. So as I up this, it's almost like this gray type of, this kind of milky look is happening to it. And then finally, you've got a gamma adjustment, which can give you just contrast, right, as you adjust it. Now, these last three settings, you're not meant to really mess with these too much, right? These are for subtle adjustments, right? So you shouldn't be jacking these sliders around, right? You might need to slowly increase the multiply, maybe offset it just a hair or two, right? Nothing too drastic. In fact, with color, you don't ever really color drastic. Color correction is all about the subtlety. So it's adding a little bit of color here and removing a little bit of color there, right? That's essentially kind of like the breakdown of a grade node and what these settings are doing here. But let's kind of use this in a more practical sense, all right? So this shot here, again, this is a typical type of shot that you might get. Now, what's wrong with this? Camera was not calibrated for indoor lighting in those lights that they were using. It was calibrated for some other lighting or maybe outdoor lighting. So when they shot this, the white balance was off, okay? It's common to get shots like this. Now, most of the times you might have a slate. Now, again, if you don't have something like this in your plate, then you just have to determine what should be white and what should be black in the shot. Now, this is a pretty easy shot because we all know stormtroopers should be white, right? If we're needing to determine what should be white in this shot, probably the stormtrooper, okay? So what we can do, I'm going to do this a manual way so you guys can see how this works. I'm going to sample these values here right on his chest. Now, what I'm doing is holding down Shift Command to get this little red bounding box. All right, and what Nuke is doing is it's looking at every pixel inside this red little bounding box and giving me an average down here at the bottom. So look at these values that we see in the red, green, and blue channel. All right, remember, we're working in additive color. So if I need to neutralize this, how do I do it? What do? I got to add in, if you look, a little bit of green and a whole lot of blue, right? Because I got to get it to that 0.63 that matches the red. You don't want to take the red out. Remember, that's not how we color correct. We work in an additive space. So we add in green and we add in blue to neutralize it. So let me show you how to do this. Again, I'll show you guys a slow way to do it, and I'll show you a much quicker way to do it. If you guys click on, for example, the white point, you click on the little color wheel, you're going to get this little tiny color wheel that's inside the node. That's not the good color wheel. Better way to do it is hold down Command and click the color wheel. This is the color wheel you want to use, the one that floats. First, it's scalable, so you can scale it, but then you have different ways of how you can color correct. Now, you guys are probably going to either use RGB or hue, saturation, and value. But you also have something called TMI. That's temperature, magenta, and intensity. Again, you guys are probably either going to stick with RGB or HSV. So let's use RGB for this, since we're color correcting RGB. I'm going to set it up so we can kind of see it all at the same time. and do it. All right, so what I want to do is grab the green and the blue and just get it as close to that 0.63 as I can. So I'm just going to add these in. All right, I'm going to back off just a little bit. This thing keeps, I'm trying to use this mouse that came with my Wacom tablet. It doesn't really work that well. All right, so again, I've got the green pretty close. Once you get to about 0.63 or so, two or three numbers, that's pretty close. Okay, so now we just need to add in a whole lot of blue here. 0.5, I'm just clicking on the next one, keep adding it in. Oh, went too far. Click on the next one, keep adding it in, get it as close to that 0.63. Okay, something like that looks pretty good. Go ahead and close this. Now let's look at our stormtrooper here. Okay, so that's, before I just did that, and now that's just doing that. See how we kind of neutralized it? But I want you guys to notice something. It's kind of hard to tell, but the image got a bit brighter, right? If you guys remember with our eyes are broken up in two different categories, right? We have what represents light and what represents color. You guys remember what those are called? Rods and cones, right? Remember I said you can kind of look at that in the digital realm with an image. You can kind of break up an image into kind of two categories. The brightness in the image, or the luma, and then the color, the chroma. So we just got the chroma, right? Now let's match the luma, okay? So it's always a two-step. You get your chroma, and then you do the luma, all right? So here's how you can look at two images at the same time. So the grade node, that's our color correction, and then the original plate I'm going to put on input 2 of the viewer. And of course you can flip between them. There's mine, there's this. So here's the wipe. These buttons up here at the top. I can basically wipe through both inputs at the same time. So if you select wipe, right, you can see the original plate's on the left and mine's on the right. And see how I can wipe between them? This is what the wipe's doing. I've shown you guys how to look at color channels, right? You can look at the red channel. You can look at the green channel. You can look at the blue channel, right? You can look at all these different channels, all right? You can also look at just the luma, or the brightness in the image, by hitting Y. If I hit Y on the keyboard, now I'm looking at just the luma. If you guys notice, it says LUM for luma. This is just the brightness of the pixel. No color information at all. So we have to match this. If you guys notice, mine is much brighter than the one on the left. So this would be your gain. All right. Of course, you could set this to a color if you want, but if you just need to bring the brightness down, just grab your gain and start dragging it down. Now, here's the key with the wipe, right? And this is how you use it. Once you see your wipe line disappear, you know you nailed it, right? So it's all about making the line disappear, all right? So as I grab the gain and bring it down, we're trying to make that wipe line disappear, right about there, all right? Nailed it. So now, if I look at the original, let's go back to Y, there is the original plate, and there is the balanced. Brightness is the same. We've just neutralized the white. Now, I didn't do black because black's not going to be as noticeable. But yes, you want to set black. So I kind of skipped over it. But yeah, you would want to say what's black. Obviously, anywhere in here probably would be black. Option Command, sample it. All right. Now, that was the slow way to do what I just showed you. There's a much quicker way to do it. All right. Again, I wanted to show you guys the slow way so you could see what we were doing, how we were adding in those values and matching the luma. All right, so if I create a grade node, load it in, you say what I want to be white, I want this to be white. So instead of grabbing the color wheel, if you click to the left of it, you're clicking the eyedropper or the color picker, whatever you want to call it. I forget what Nuke calls it, eyedropper, color picker, same thing. And you say, I want this to be white, Option Command click, bam, right? So what it just did was what I showed you. It just did it in milliseconds. So it sampled that pixel. It saw that it needed a little bit of green and a whole lot of blue. It just did it super quick to neutralize it. Again, it didn't do anything with my luma though. So I still need to adjust my luma. Right, so in my luma, I know it's a 0.64, so I could just go into my gain and hit a 0.64 and get my luma back to where it needs to be. That's another way of doing it, setting a white balance. Now that this is balanced, I could go ahead and start to do the key or do whatever I need to do. Let's talk about how you match between shots, because again, compositors, this is what we do. Remember, our whole job is making everything look like it's in the same environment at the same time. I can't stress that enough. So a lot of what we have to do is this type of color corrections, where we're matching one to the other, or we're trying to make everything look like it sits in the same frame. So again, we've got two images here. This was correctly balanced. This was incorrectly balanced. All right? And again, it's just something that you have to deal with. So I need this guy to match this guy. So I'm going to color correct this guy. Now, I want to look at both of these images at the same time. So I'm going to show you guys how to set up a workspace here. What we can do is create a new viewer. You guys know how to create a new viewer? Command I, right? That's just the quick key. And we'll load it into this guy. So now I have viewer 1 and then viewer 2. Although viewer 1, guys, I don't know if you guys have noticed, this is twice that my viewer screwed up. Did you guys see that? It happened once in lecture and it happened once in lab just now. There's no rhyme or reason why it does that. It just sometimes does that. So did you see? It's trial and error just from doing this stuff all the time. I know you guys are learning, but I'm giving you guys a hint. If something doesn't look right, delete your viewer and recreate it and see if that fixes it. Right? It's just some of the troubleshooting you can do. Obviously, something gets screwed up. I'm not really sure what happens. It doesn't really matter because I know how to fix it. I just delete it, create a new one, and I keep moving forward. All right. Anyway, let's show you how you can look at both these viewers at the same time. Right? If you notice, we have the viewer tabs up here, but to the left, we have this little button. Right, and this is where we can split these panes up, right? So I'm going to split this horizontally, right? So now I have this other pane off to the right, and I'm just going to move this guy. We'll move viewer 2 over here, right? So now I can see both of them at the same time, okay? And of course, yes, I could go to my workspace and save this out and recall it whenever I need it to. We're going to grade this, all right? Remember with the grade node, we start at the top and we just work our way down. So the first thing I need to do is define what should be black in this image. So let's look at this image. What do you guys think should be black? Not what looks black, but what should be black. His pupils, very good, right? That's probably the only area where I know that's supposed to be black. Okay, again, you might say, well, the shadows, but remember, this is a blue shirt. That's probably not black. That's probably like a dark blue. You know what I mean? Now, again, since we're dealing with black, you're not going to see much of a difference. Option, Command, and click. Now we just need to define the white point. So what do you guys think should be white? Okay, so we're going to go to white point, Option, Command, click, and set the white point for his eye. All right, so we're getting close. Now we have the lift and the gain. If you guys remember what I said earlier, the lift and the gain are for remapping this black and white point. So the lift will remap this black point, the gain will remap the white point. So basically what I want to do is grab the black and white point from this guy as the lift and gain. So what should be black in this one? And you guys probably could say this area because he is wearing a black shirt. So that's probably the best bet. If you're going to say the darkest area, it's probably going to be right around in here. So for the lift, I'm only going to hold down Command, right? I said you had to hold down the Option modifier to sample before the node, right? Well, remember, I don't have to hold down Option when I'm sampling because this particular file is not passing through the node. You see that? So I don't need to hold down that Option key. I can just sample with Command, all right? So there's my black point, right? And then my white point, you're going to notice it immediately when I start adjusting it here. And just from doing this, I know my best bet is probably to get it somewhere in his eye. So if I start sampling his eye, right, you can see we're starting to get much closer to matching it to the right, okay? So now, this is where we use our multiply, offset, and gamma. Remember, this is just for fine-tuning it to kind of just nudge it where it needs to be. You're not going to ever crank these or jack these around like this. That's not what these are for. This is for, okay, my multiply, maybe it's still not quite, the exposure is not quite there. I might need to up it just a little bit, right? Or maybe my darks, or maybe everything's just still a little too contrasty. Maybe I need to up my offset. Again, these are supposed to be very subtle adjustments you make with these guys here. Again, you're not going to move these sliders around. If you need to add a little bit more contrast, you can decrease the gamma amount if you need to. Again, but those are what those settings are for. So this is how you use a grade node, right? And this is the point of a grade node. It's for being able to grade or match an image with another image, essentially, right? If you guys remember chromatic aberration, I briefly talked about it in our first lecture, right? It's when light passes through glass and refracts, right? And we have all that glass in our lenses to kind of redirect that light. Unfortunately, it doesn't always focus to the same point and it creates this aberration. Again, every lens is going to have some amount of aberration and it gets progressively worse as it gets to the edges of the lens, right? So you're not going to notice it as much in the center of the frame. As you go towards the edges of the frame, you'll notice it progressively worse. There's multiple ways to do this. In fact, in the intro into Nuke, you did it with the God rays, right? If you went to if you went through all the podcasts, the very last one where you add in the chromatics, he does it with that node called the God rays. Oh yeah, here we go. So look at this. This is a shot here. This is from an info commercial. This is going to be your planar assignment. But what I want you to look at is the chromatics. Now, do you notice it? So you're not going to notice it much here, but look when I start to get here. This is chromatic, right? You see the magenta? You look around her glasses. You see this? Now notice it's green and magenta. okay? Usually, not always, but usually if you see a green magenta chromatics, that's telling you that this is digital. How can we match this? Well, let me show you kind of the most obvious way. And that's just what we're doing with the checkerboard, is you're just going to kind of separate the color channels, merge them back together, and do kind of like mess with it in between. So for example, I'm saying just give me the magenta. So in the shuffle node, I'm saying only shuffle out the red and the blue. You notice it's ignoring the green channel. The other shuffle node, it's the complete opposite. It's only shuffling out the green, it's ignoring the red and the blue. All right, now they're just getting added back together, so eventually we've got no difference. But here's how the chromatic works. In between, I'm going to scale the magenta channel, and you always want to do it on scale. Don't do translation. People may try to tell you to translate it. That's not correct. You scale it. And the reason why is because watch what happens when you scale, right? Okay, so let me do something a little bit more exaggerated so you guys can see it. There we go. Okay, so you guys can see it, right? So look, the center of the image, you're not seeing much. As we get progressively to the edges, see how it gets greater and greater and greater? In fact, it's almost starting to give that round look like it is a lens, right? Now, again, this is very, very extreme. You don't ever throw this type of chromatic aberration in your shot, ever. That's one way to do it. You can set it up like this. This is kind of the most visual way to do it, where I'm just shuffling this out, right? And then we're just adding it back together and we're setting it up. You guys can do it however you want in your scripts, right? You don't have to do it this one way. I'm going to show you guys 3 different ways. All right, so we can also use what's called a transformed mask node. So if you tab this in, make sure you tab in the right one. Transform masked, right? Now the only difference between this transform and a transform mask, so here's a typical transform and a transform masked, right? Transform mask gives you control over individual channels, just like I could do over here. So for example, I could say, okay, let's select RGB, let's plug it in, you could say, well, let's only affect the red and blue channels, and let's start upping the scale. Guess what I'm doing? Whoa, that looks very similar to what I was just doing over to the left, right? Again, all I did was I just turned off the green channel, right? I'm just adjusting the scale. Again, when you're doing chromatic, you do the scale. Don't move, translate. That's not doing chromatics correctly. I've seen students translate it for some reason, so don't do it that way. Do it with the scale. Now, not only do we have to deal with the chromatics, we have to deal with, finally, what is the last stage? When the light hits that sensor, or it hits the film. So the grain stock, or the noise, we have to incorporate, right? And you guys are going to match the noise from the back plate to the truck. Now, again, this was shot on film. This is film stock, right? And I want you guys to just look at this grain in this image. You guys see it? Again, you can't remove that. You can try to denoise, but what you're going to do when you denoise is you're just going to blur the image. You're going to degrade it, lose quality. So that's why we have to add this stuff into the CG as opposed to trying to remove it out of the live action, which we're never really going to be able to do. It's not going to look right. Let's say we have some CG here. There's my CG. We're going to pretend this is something else, right? But what we want to do is get this grain stock or grain pattern onto this, okay? So we can use what's called the F regrain. Now the F just stands for furnace core. That's just the plugins that come with Nuke. If you guys look, the furnace core plugins are all down here. Unfortunately, we just don't have time to go through a lot of these plugins, but we will talk about the regrain here. We are going to grab our source and grab the grain pattern from here, right? Now, if I load the F regrain into the node, it's going to say, please provide an analysis region to grab the grain stock. So whenever you're trying to sample for grain, always try to find something that looks very neutral. So if you can find grain against something that's gray, that's what you're aiming for. You don't want to find, or you don't want to sample from something that's too dark, where you're going to get unrealistic or it's too much grain. Somewhere in this area is probably going to be my best bet. So if I sample this area, right, and now if you notice, there is the grain stock on our CG gray card. Do I dare do this? Okay, yes, because that brings up a good point. You guys can see it, but I want you guys to look. Let me jack this all the way up. Hope I don't crash. Okay, look at all this crap. You see all this happening? This is very, very, very bad. And the reason why is because this image is pre-multed, right? The F regrain is not like pre-multiplied images, right? And that's what it's doing. What it's doing is it's taking that last pixel that's at the very edge and it's just stretching it all the way to the end of the resolution of the viewer, right? Now, if you were to comp this over, this is bad. You don't want to comp this junk over your live action plate. what you have to do with the F regrain, and you guys need to do this too when you add the, if you do it this way with the F regrain, is you need to unpremult first, all right? Then pre-molt, do your F regrain, and then pre-molt after. Now you'll notice you're not getting any of that stuff. You composite it over. You guys can see it on the, hopefully you guys can see it on the projector. See, it's much more integrated in now.